Hi guys, so today we're going to be continuing to learn about circles, specifically arcs and chords. And before we get started, let's talk about one of our theorems in regards to arcs and chords. So in a circle, or in congruent circle, if there are two minor arcs that are congruent, so example here is arc AB is congruent to arc DC, okay, then what we know is that the corresponding chord, right, so the line connecting AB and the line connecting DC are also congruent, okay? And then the opposite is also true, right? So if chords are congruent, arcs are congruent. If the arcs are congruent, the chords are congruent. It makes it nice and easy, okay? So with that, we're going to be kind of proving the reasons why in example 1. So here, we want to prove in a circle, or in congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. Okay? So we're going to start first with the fact we are given there's a circle with the center X. Okay? We have two arcs that are congruent, so UV, so that's this one here, and YW here. These arcs are congruent. Okay? Then we want to prove that the arcs, that the chords that connect them, UV and WY or YW, are also congruent. Okay? So here we're starting off with our given. Okay? And then from here, what are some of the things we notice? Okay? So here we notice that angle UXV, which is this angle here, has to be congruent to this angle here, WXY. And the reason why is because if the arcs are congruent, their central angles have to be the same thing too. They have to be the same measure. Okay? Then the next part looks at UX, XV, XW or WX, and XY. If we notice, all of these are center to the circle, and so that makes them the radius. That's definition of radius. And so we know that all radii of a circle are congruent. Okay? So as a result then, we have side, angle, side, and so we can prove that these two triangles are congruent using the side, angle, side congruence postulate. And if triangles are congruent, then their parts have to be congruent too with CP, and so that would make UV congruent to YW. Okay. So why don't you try CYP2, and then once you're done, come check your answer. Okay, you should have gotten something similar to this. So starting with statement 1 is my given, circle A and arc, there's circle A exists, and then arc BC is congruent to arc DE. The reason I can write that is it was given to me. Okay. Then angle DAE, which is this angle here, is congruent to angle BAC, which is congruent here. And the reason why is it's built off of this arc congruence in my given, is that if arcs are congruent, their corresponding central angles are congruent as well. Okay. Another way you can do this is probably stating that they're vertical angles. That would work too. Then the next part is talking about the sides of these angles, which is DA, AE, AB, and AC, and all of these are radii, right, because they go from the center of our circle to the end of our circle, to the edge of our circle. So as a result, all radii of a circle are congruent, so each of these segments are congruent as well. Okay? And then as a result, these two triangles that we see here are congruent. So triangle DAE is congruent to triangle BAC because of side, angle, side congruence postulate. Okay? And so if triangles are congruent, then their corresponding parts have to be congruent. So since BC corresponds with DE, BC is congruent to DE because of CPCTC. Corresponding parts of congruent triangles are congruent. Okay, so now let's move on to example 2. So here we have a regular octagon. So again, regular means that the side lengths are the same, as well as the interior angles. Okay, so here our rectangular octagon is inscribed into a circle. Okay. if opposite vertices are connected by line segments, we want to know what is the measure of angle ACB. Okay? So here within this circle, it's now basically broken up into 8 parts, right? And our circle is 360 degrees, so if we did 360 degrees divided by 8, okay, then that would equal 45 degrees, okay? Which means each piece or each central angle here is 45 degrees. And then I could keep going around, okay? Here, since ACB is 3 of the pieces, then to find out what that is, I can just do 3 times 45. Okay. And that gives me 135. And so, angle ACB would be 135 degrees. And there you go. So why don't you try CYP2, and then once you're done, come check your answer. Okay, so for number 2, you should have got in G, 72 degrees. The reason why is then it'll be split up into different parts, right? And so then your regular pentagon, right, will be split up into 5 parts. So 360 divided by 5 is 72. And so it's each 72 degrees. Okay, before we move on to our next example, let's take a look at our next theorem that we're going to be talking about. Okay. So here, in a circle, if a diameter, so in this case diameter here, is perpendicular to a chord, so my chord here is TB, then what it does is it bisects the chord, so then TU equals VU, and it also bisects the arc, so that TA and VA are congruent. Okay. Okay, with that in mind, let's look at example 3. Okay, so here circle O has a radius of 13 inches, and so what that means is OB is 13 and OC is 13 as well. And then we know that radius OB here is perpendicular to chord CD, which is 24 inches long. Okay. So we know this whole thing is 24 inches long. So basically, some things we should know. Radius is 13 inches, so that means this is 13 inches, and since we drew this, this is 13 inches too. Okay. And then we know CD here, so that's all of this, is 24 inches. Okay. So here, A tells us that if the measure of this whole arc here, CD, is 134, what would be CB? Okay, and so what we know is that if our radius and our chord are perpendicular, it bisects it. So CB would be half of CD. So half of 134 is 67. So the measure of arc CB would be 67 degrees. Okay. The next one here asks us to find OX. Okay. Okay. So then we also know that if a chord and a radius are perpendicular, it bisects it. So if this is 24 inches, that would mean that CX now is 12 inches because half of 24 is 12. Okay. Note here that this forms a 90-degree angle. So the radius is 13. This is 12. We can now find OX. Right? So it would be OX squared plus our other leg is 12 plus 12 squared equals our hypotenuse here, which in this case is the radius. Okay? So 12 squared is 144, 13 squared is 169. If we subtract 144 on both sides, that gives us 25, so OX squared is 25. Get rid of the square by square rooting it, and so OX equals 5 inches. And there you go. Okay, so why don't you try CYP 3A and 3B, and then once you're done, come check your answer. Okay, so for 3A, you should have gotten 55 degrees, and for 3B, RS is 3 squared root of 15 centimeters exactly, or approximately 11.62 centimeters. Okay, if you got that right, you can move on to our last example. If not, here is your explanation. Okay, so here we have a radius of 16 centimeters. So this is my radius here. And this radius RU is perpendicular to chord TV, which tells us then that this arc is bisected and so is the chord. Okay? And the chord is originally 22 centimeters. Okay? So here, if the measure of arc TV is 110, if it's bisected, we can find UV, right? So 110 divided by 2 is at 55. Right? Then, to find RS is this tiny section here. Okay? Note that RV is a radius because it is center to the edge here. Okay, that's a radius. And then this SV here was our chord that got bisected, and so that's why it is now 11. Okay? And so then, since this forms a right triangle, I can use Pythagorean theorem. So RS squared plus 11 squared equals 16 squared. 11 squared is 121. 16 squared is 256. Subtract 121 on both sides, and that gives you 135. Get rid of the square by square rooting both sides, and that gives you square root of 135, which simplifies to 3 square root of 15, and that is approximately 11.62. Okay. And then here on our last example, before we get to that, let's talk about our next theorem. Okay. So in a circle or incongruent circle, if two chords are congruent, they have the same distance from the center. Okay. There you go. Okay, so let's look at example 4. So here, chords AC, that's this here, and chord DF is equidistant from the center. Note that they're both 10 units away. Okay. If the radius of G is 26, so we have several radii here, right? Because radius is just from center to edge, so this is a radius and this is a radius too. And it asks us to find what AC and DE is. So first, what we're going to do is we're just going to find one of them. Okay, they're going to be the same anyways. Okay, so here, since this is 26, this is 10, I can find what this is using the Pythagorean theorem because it forms a right triangle, right? So 10 squared plus AB squared, which is the same as EF squared, will equal 26 squared. 10 squared is 100. 26 squared is 676. Subtract 100 on both sides, and that gives me 576. And then square root both sides, and this gives me 24. And so AB has a length of 24. So would EF, right? And then what we learned is that from a radius, so if we continued this here, right, and this became a radius, and if that is perpendicular to our chord, it bisects it, right? So if this is 24, this would be 24 too, and so 2 times 24 would give me 48, and so AC, which is this, 24 plus 24, and DE, okay, so DE is 24 because it's only here to here, but AC is this whole thing, so AC would be 48. Okay, so why don't you try CYP4, and then once you're done, come check your answer. Okay, you should have gotten that MO is 8 square root of 11, which is approximately 26.53. And PQ is 4 square root of 11, which is approximately 13.27. If you got that right, you can get started on your homework. If not, here is your explanation. Okay. So note that chords MO and PR are equidistant from the center. Okay. So then what that means is that distance is that perpendicular part, right? So if the radius of S is 15, so this would be 15 and this would be 15. Okay, we can figure out what this is and what this is using Pythagorean theorem because it forms a right triangle, right? So then, mn squared plus 7 squared equals 15 squared. MN would be the same length as PQ, like identical triangles. Okay. Then using Pythagorean theorem, 7 squared is 49, 15 squared is 225, 225 minus 49 is 176, square root both sides, that's 4 square root of 11. Okay. So that means this is 4 square root of 11. Okay. And then remember that if a radius, okay, so I could keep moving this like that, right? So that way it's a radius. If a radius is perpendicular to a chord, it bisects that chord, right? So that means this is 4 square root of 11, this would be 4 square root of 11 too. So the whole thing would be 2 of them. So 2 times 4 square root of 11 is 8 square root of 11. And then PQ we found earlier with the same way as this, so that's 4 square root of 11. Okay. So that's it for today. Have a great rest of the day. Bye guys.